Polygons is our new lesson for today. Let's see what a polygon is, what we're going to learn. They're all two-dimensional, so you can draw them accurately on a flat piece of paper. Poly means many, and anytime you hear the suffix gon, it's talking about a figure, a drawing. Okay, so a polygon is a many-sided figure, sides meaning straight lines. One classification of polygon is the convex polygon. Convex means to go outward. You have convex lenses in microscopes and telescopes and magnifying lenses and glasses. Okay, so convex means to curve out or to go out. So it's a polygon is a formal definition such that no side of the polygon contains a point in the interior of the polygon. So no side goes inside the polygon is basically what it means. And I'll draw some pictures here in a minute. Another type is the concave. Concave caves in. So the sides can go inward to the interior of the polygon. Formal definition is a polygon that has at least one side of the polygon containing a point in the interior of the polygon. So at least one side goes into the polygon. Okay, so let's see what the difference in the way they look. Okay, let's take this one here. We have straight sides. They're all connected to each other. It has to be closed. There can't be any open gaps for it to be a polygon. And we have these sides here that are going into this interior region of our polygon. So do you think that's going to be concave or convex? If it caves in, it should be concave. Here's what a convex polygon would look like. Okay, again, made of several straight line segments, all touching each other so that there's no gaps. But none of the sides come into this interior portion. So is it concave or convex? You should have said convex. Okay, so two different ways to classify polygons. They can either be concave or they can be convex. Now we have different names or different types of polygons. If it has three sides, you're familiar with this one, it's called a triangle. We're going to go through all the different number of sides and what their name is called all the way through to 10. You need to know these. You need to have them memorized. You will probably have a quiz over them. Okay, so if it's a four-sided object, we call it a quadrilateral. Quad means four. Some people call four-wheelers quads. Right? That's why they have four wheels. Five sides is called a pentagon. Our government has a big building they work out of called the Pentagon. If you look at it from up in an airplane, if you Google Pentagon, you will see that building come up, and it is in the shape of a pentagon. Six sides is hexagon. Okay, from this point on, we are going to end everything in the suffix gon. So pentagon means 5, hexagon means 6, heptagon means 7. And those are very similar, so be careful not to get them mixed up. Hexa, 6, hepta, 7. You should be using these in chemistry as well, so perhaps you're familiar with them. 8, octagon, like an octopus, has 8 legs. Nonagon means 9. Kind of put those two together because they both have 2 ends in them. Nonagon is a 9 sides. And a decagon is 10 sides. Anything above 10 They do have their own special names, but we can also just use numbers. So I could put 12 here. If I put 12, then I have a 12-sided object and I just call it a 12-gon. 12-gon. I put the number 12, 1, 2. Okay. If it had 28 sides, I would put 28-gon. Okay. Another way to classify polygons is to call them regular or not. If it is regular, then the polygon is both equiangular and equilateral. Well, what do those words mean? You have to know what those words mean in order for this definition to make any sense. Equi means equal. Angular means angles. So all the angles in that one polygon are congruent. They all have the same measure. Equilateral means equal sides. So the side lengths are all equal or congruent. Okay. So again, sides are all equal and angles are all equal. So it would look something like this. What would we call this six-sided object? If it has 6 sides, it would be called a hexagon. Is it concave or convex? Hopefully you said convex because none of the sides are caving in to the interior. Notice we have marked all the sides congruent and all the angles should also be marked congruent. Whoops. I keep doing this. It's really hard to make arcs on the computer, so I'll draw them in so that our angle measures are also marked congruent. If they're not, you should not assume. So when you see all sides and all angles marked congruent, you know it is a regular polygon. You would see these markings or you would see actual angle and segment lengths. But you have to be told, we're not going to assume. Okay. Naming polygons. How do we name a polygon? Well, all the vertices will be named as points. So you have these capital letters. You will start at one of those points and you will work your way around in order. We usually go clockwise. So it says to list its consecutive vertices in order. Consecutive meaning one right after the other. So we're going to start with A. We would name it B, C, D, E, F. And yes, you have to name all of them. So again, this being a hexagon, we should have 6. So we would name the hexagon A, B, C, D, E, F. So however many vertices there are, that's how many points you should have in its name. Okay, so be able to name polygons. And when you read the name of a polygon, be able to identify which one that name is referring to. All right, perimeter. You should be familiar with that word. It's the distance around a polygon. You find it by adding up, sum means addition, or adding up the lengths of the sides. So if we have a triangle, the formula is going to look like this. The perimeter is going to be the addition of all the sides, A, B, C. For a square, because all the sides are the same, you're just taking one side and multiplying it by 4. Or you could add them all up, if that makes more sense to you. A rectangle, because we have 2 pair of congruent sides, we can take the length and multiply it by 2. Take the width and multiply it by 2, and then add them together. Again, you're always good with just going around the outside and adding all of those sides together. That definitely works. Notice a circle doesn't have any sides. So we don't call it perimeter because we're not adding up sides, but it is still the distance all the way around it, and we call it circumference. So you need to know that word. Circumference is the distance around a circle, kind of like the circle's perimeter. And the formula for that is 2 pi r. What do you think r stands for? R stands for the radius. So let's do a couple of examples here. All right, so I have a rectangle here. If I say that its length is, say, 10 and its width is, say, 2, what is its perimeter? Well, because it's a rectangle, if this length is 10, I know this length is 10. And mark up your pictures. Always draw in what you know so you can see all of the relationships. If this width is 2, then I'm safe in saying this width is 2. So I have 2 10s. And I have 2 2s. And I can add all of that together. 2 times 10 is 20. 2 times 4, or I'm sorry, 2 times 2 is 4. Add those together, and my perimeter is 24. Okay, so know how to use these formulas. Here I have a triangle. We're going to make this an isosceles triangle by showing that those two sides are congruent. So if I know that this side is 4, and I know that this side is 3, goodness gracious. What is the perimeter? Well, the perimeter is all 3 sides added together, but I only have 2 sides given to me. How do I find this third side? So here's, how geometry works. You're expected to know these relationships and use those relationships to take the information that is given to you and fill in the blanks to answer the question. So what do you already know? Well, you know that these 2 sides are congruent. If you remember what congruent means, it means that they are the same measure. So if this is 4, then I can fill in this blank here by putting another 4. Now I can go answer the question. The perimeter is 4 plus 4 plus 3, which is 11. Okay. Make it a habit to show your work and box in your answers. Okay. So again, be able to use those formulas for perimeter. Perimeter being distance around. Now, if we want to know how much area it takes up, how much it takes to fill in the inside, we want to find the area, which is the number of square units needed to cover a surface. The units are always going to be squared. So we tend to measure in centimeters in this class. So if you were measuring something, you would call the dimensions centimeters, 5 centimeters, 2 centimeters. And then when you use them to find area, you would call your final answer something centimeter squared. So be able to use these formulas. For a triangle, the area is 1/2 the base times the height. Now, the height is the tricky part. Height being how tall the triangle is from the base straight up to that top vertex. So this is my height. It's not this slanted part, it's straight up. Sometimes it'll be given to you. Sometimes you're going to have to find it by using Pythagorean theorem. So understand that height is straight up. For a square, because all the sides are the same, you can just take the two sides, length and width, and multiply them together. So you're squaring the sides. The area of a square is one of the sides squared. That's why it got its name, square. A rectangle is length times width, which you should already know. And a circle is pi r squared. What does the r stand for? Radius. Remember, you need to write that in. Jot yourself a little note. So let's work a couple of problems here. So let's just make up some numbers here on this rectangle. Let's say this is 15. And let's say this is 5. Well, according to our formula, the area of a rectangle is length times width. So again, we work in a methodical way, writing down our formula first and then going directly underneath each letter, filling in the blanks. We don't know what the area is, so we're leaving that blank. The length is always the long side, so we call that 15. And the width is always the short side, which is 5. So length times width here would be 75. And then box in your answer. Work methodically so you don't skip steps and make careless mistakes. That way I can go back and look and see your work and determine where you messed up if you got the answer wrong. All right, here is a triangle. Area equals 1/2 base times height. Now I told you the height has to come from the vertex straight down. You should see a right angle box there. What in the world? Just got to do it faster, I guess. So let's say that this height is 2 and that this base down here is 4. Again, we just plug it in. 1/2. My base is 4. My height is 2. And you could approach this in many ways. I go on and take half of my first number, especially if it's even. It's really easily cut in half. So half of 4 is 2. Now I have 2 times 2, which is 4. Okay, now circle. Formula for the circle. Pi r squared. So we have to know the radius. Okay, again, let's just say this is 2. So we're going to work our way down, filling in the blanks. You can leave pi in your answer for this class. I'm totally okay with that. Or you can put 3.14 if you want to. I'm leaving pi in my answer. My radius is 2, and I need to square that. What does it mean to square a number? It means to multiply it times itself. So 2 times 2 is 4. We usually put the coefficient or the whole number first and then the pi symbol. So we would say that the area of this circle is 4 pi. This slide just puts it all together, so you have the perimeter and circumference along with the area formulas all in one place. So if you want to take a picture of that, print it out, or what have you, just refer to it in the future. And that is today's lesson on perimeter, circumference, and area of polygons.